Hello, hello. We are back, and once more, we're going to be dealing with some composite functions. So, first thing we're going to do is start off with the homework from the last video. So, let's say that, I had number one was f of x equals x cubed plus 3x. First thing it wanted was what f of 5 would be. Well, f of 5 would just be 5 cubed plus 3 times 5, just like that. Okay? And then we went from 5 to f of star. What would f of star be? Well, f of star would be star cubed plus 3 times star. And last but not least, my favorite, f of a smiley face. Get the pen to draw the eye. Well, that's a terrible looking smiley face. That's okay. Well, that's just going to be smiley face cubed. Wow, I am having trouble getting the smiley face to look right. Plus 3 times smiley face. Just like that. All we did is do a substitution. Since this is f of x is x cubed plus 3x, we just do a substitution. So f of 5 would be 5 cubed plus 3 times 5, and so forth and so on. So that's how that one worked. Now if we move down to the next one we had was if f of x is equal to x plus 1 and g of x was equal to x squared, what is f of g of x equal to? Okay, so all we have to do is use the exact same procedure that we did here. F of x is x plus 1, so f of g of x is going to be g of x plus 1. And now what is g of x? Well, g of x is x squared, so I can do that substitution. X squared plus 1. And note that the g of x is our interior function right here, and it appears untouched within the final answer over here. The x squared is untouched. So just to key that in, because that is going to help us down the road. So let me clear the screen and we will do number 3. So if I can clear the screen properly, here we go. Number 3 is going to be f of x is equal to 2x squared plus 1, and g of x is equal to negative 3x plus 5. All right, so we wanted, first off, f of g of x. Okay, we're going to do it just like we did before. So f of x is 2x squared plus 1, so f of g of x is going to be 2 times g of x squared plus 1. And since I know that g of x is negative 3x plus 5, I just substitute that in. So 2 times negative 3x plus 5, quantity squared, plus 1. And you can leave it just like this. This is way easier to understand what you did than if you try to square everything, distribute the 2, and then collect all like terms. That's going to obscure what happened. So leave it just like this, totally fine. So let's go for the last part, g of f of x. So g of x is negative 3x plus 5, so g of f of x is going to be negative 3 times f of x plus 5. And then what is f of x? Well, f of x is 2x squared plus 1, so this becomes negative 3 times 2x squared plus 1 plus 5. And that's it. That is your answer right there. So hopefully these are making more sense. They are initially kind of odd. It's a very strange way of looking at things, but once you get it down, it's impossible to ever see it the same way again. You automatically just see it. So it usually just takes a lot of practice. That's what we're going to work on today as we continue. I'm going to clear the screen and we will dive into the remainder of the lecture. So here we go. Clear the screen. And let's jump straight in. So we're going to start off with something that looks bad, but it's actually not going to be bad at all. Let's start off with f of x equals, let's do x cubed plus 3x squared minus 4x plus 7. Okay? And then g of x is going to equal x plus 5. Okay? Now, here we go. What is f of g of x? Okay? F of g of x is, instead of x, I'm going to have g of x cubed plus 3 times g of x squared minus 4 times g of x, and then plus 7. Okay? And now I can do my substitution. What is g of x? Well, g of x is equal to x plus 5 quantity cubed plus 3 times x plus 5 squared minus 4 times x plus 5 plus 7. And that's our final answer right there. I think this really brings home what's going on. I'm replacing every x in my f of x with x plus 5, which is the g of x. Every x gets replaced by the g of x. So every x becomes x plus 5. Just like that. Okay? Now, let's work the problem again, but let's use slightly different variables and numbers just so we get some good practice. Let me clear this. Let's make a nice complicated one. F of x is equal to 5x cubed minus 6x squared plus x minus 4. G of x is equal to, let's go with 7x cubed minus 3. Okay? So what is f of g of x? Every x gets replaced by g of x, so this becomes 5 times g of x cubed minus 6 times g of x squared plus g of x minus 4. And now I can do my substitution. 5 times, well, g of x is 7x cubed minus 3, quantity cubed, minus 6 times 7x cubed minus 3 squared, plus just g of x, so 7x cubed minus 3 minus 4. And now, hopefully it's really clear what's going on. Where there was an x in the original expression, there is now a g of x substituted in. And that's all that's going on. Now, once you see this, sometimes it's easier to work the problem out without doing this g of x step. So I'm going to go ahead and warn you, you do not have to do it this way, and it may confuse some people. So if you like this way and you don't want to go for the next one, just jump ahead in the video until I pass it up. But if you want to see how you can kind of shortcut this, let's try this. Let's do f of x is equal to x to the 5th minus 4x to the fourth plus 3x squared minus 7. And g of x is equal to, how about x cubed minus 10? X cubed minus 10. So f of g of x, okay, is going to equal, well, wherever there's an x in my original expression, I am going to substitute what g of x's value is, which is this x cubed minus 10. If you want, you can go straight there. I can just make this quantity, instead of x to the fifth, x cubed minus 10 to the fifth, minus 4 times, instead of x to the fourth, x cubed minus 10 to the fourth, plus 3 times x cubed minus 10 squared minus 7. Some people, including me, like to go straight there. They have the original expression, they have what's going to be substituted for all the values of x, so they just go ahead and plug it in. And that way sings to some people much more than using the g of x placeholders. Whichever one you like, totally fine. They both get to the same answer. It's just this one is kind of shortcutting it a little bit. But if you like it this way, that works. What if I had h of x is equal to negative 4x plus 2? What would f of h of x give me? Well, same thing. Negative 4x plus 2 to the fifth minus 4 times negative 4x plus 2 to the fourth plus 3 times negative 4x plus 2 squared minus 7. What changed? The middle of my composite function changed. We went from g of x, which had everything as x cubed minus 10, to h of x down here, and h of x was negative 4x plus 2. So I'm super hopeful that this is making sense. If it doesn't, definitely come to the office hours and we'll work through some examples. But hopefully this is clicking. So let's move on to some different problems. I'm going to clear the screen and we will continue. So clearing the screen and we'll continue. So let's see. Let's start off with f of x. This is going to look kind of odd, but it's not too bad. F of x is equal to x plus 1. G of x is going to equal to negative 2x plus 3. And then let's go with h of x is equal to x squared. J of x, I know, is equal to root x. And finally, k of x is going to equal x cubed plus 2x. Okay? So now let's try f of g of x. Well, f of g of x is f of x is x plus 1. So f of g of x is going to be g of x plus 1. What is g of x? G of x is negative 2x plus 3. So negative 2x plus 3 plus 1. Okay? Then what about f of h of x? Well, that's just going to be h of x plus 1. What is h of x? H of x is x squared. So it becomes x squared plus 1. I'll keep it in parentheses just to keep it consistent. Alrighty. What about f of j of x? Well, that's going to be j of x plus 1. And what is j of x? It's root x plus 1. And finally, what about f of k of x? Well, that's just going to be k of x plus 1, which is x cubed plus 2x plus 1. Okay? Now let's do it with the shortcut way, the slightly faster way. So let me give y'all a sec to look at it, stare at it, pause it, and then I will erase it. So I'm going to erase everything that's over on this side. Actually, make my eraser a little bit bigger where it doesn't take as much. Much easier than the board, I can tell you. Alrighty, so now let's go back to filling this out, but let's fill it out sort of with that shortcut in mind. I'm going to replace every x in my original expression by what's in the interior. So, in this case, that is negative 2x plus 3. That's what g of x is equal to. So this becomes negative 2x plus 3 plus 1. Then I move down to f of h of x. Well, that becomes x squared plus 1. The next one, j of x is root x plus 1. And finally, for k of x, I get x cubed plus 2x plus 1. I'm just substituting in wherever there's an x in my original expression. When I do f of g of x, I substitute g of x in for that. F of h of x, I substitute h of x for that. J of x, the same. And finally, k of x is done identically. So it goes, this is my g of x right here. This is h of x. Well, that's a bad x right there. This is j of x. And this, oh, I don't know why I did parentheses there. That's weird. This is k of x. Okay? So that's how this works. There's not a whole lot else to it. It's just getting comfortable with doing this composite function stuff. So let's do another one, and we're going to make it just a tad bit more complicated. So I'm going to clear the screen. Alrighty, let's do f of x is equal to negative 3x squared plus 5x minus 2. G of x is going to be x plus 7. H of x is going to equal negative 4x minus 1. J of x is going to equal x cubed plus 5. And k of x is going to be root x plus 2. Okay? So over here, when I want to do, let me do a little divider so we can keep this separate. F of g of x, what does that equal? Well, wherever there's an x in my original expression, I'm now going to substitute what g of x is. So this becomes negative 3 times x plus 7, quantity squared, plus 5 times x plus 7 minus 2. Okay? Now what about f of h of x? Well, f of h of x, I'm going to replace every x with negative 4x minus 1. So this becomes negative 3 times negative 4x minus 1 squared plus 5 times negative 4x minus 1 minus 2. Then if I do f of j of x, I'm going to get, well, I'm going to replace every x with x cubed plus 5. So negative 3 times x cubed plus 5 squared plus 5 times x cubed plus 5 minus 2. And last but not least, f of k of x. Well, that's going to be, replace every x with root x plus 2, so this becomes negative 3 times root x plus 2, quantity squared, plus 5 times root x plus 2 minus 2. And that's it. And I hope this is becoming a lot more comfortable. We're going to work just one or two more. I'm going to give you your homework and then turn you loose. So let's go ahead and clear this and start in on the last few examples. So clearing the screen. Okay, let's say that we have something like f of x equals x squared plus 5x. G of x is equal to root x. Okay? What would f of g of x be? Well, I'm just going to replace every x in the original expression with g of x, what its value is. So this is going to be root x squared plus 5 times root x. Okay? Now what would g of f of x look like? Well, now I'm going to replace every x with what f of x is. So it's this whole thing. So g of f of x is going to be root, and underneath is going to be x squared plus 5x. That is taking the place of x. And if we look one more time, if you want to make sure which one you've done, f of g of x has g of x untouched in the answer. Root x, root x, root x. G of f of x has f of x untouched in the answer. And there it is right there, x squared plus 5x. So that's how you can always tell which one which of the composites you're doing when you substitute in, because I know that's confusing, at least when you first start doing this. So that's that. Now, this is going to be a very, very strange question. Here we go. This is for all the marbles. What would f of x be? Okay. Well, I would replace every x in the original expression with the entire expression. So instead of x squared, I'm going to get x squared plus 5x squared. And then for this x, I'm going to get plus 5 times x squared plus 5x. This is as confusing as it gets, but every x in my original expression gets replaced by the entire f of x. So instead of x squared, it's x squared plus 5x squared. Instead of x, it's x squared plus 5x. That's the limit of confusing. If you can follow this, you can do any composite function I can throw at you. I can't get worse than that. So hopefully this makes a good amount of sense, and we can push forward. I'm going to give you some tricky homework, and we will go from there. So let me clear the screen, and let's go for homework number 1. Let's do something a little more traditional. Let's do f of x equals maybe 2x plus 7, g of x equals x squared. What is f of g of x? And what is g of f of x? Okay, now for number 2, let's make it a little bit more interesting. F of x is equal to x cubed minus 3x plus 5, and g of x is equal to x plus 7. What is f of g of x equal to? All right, now for the big one. Here we go. Number 3. F of x is negative 5x plus 2. You know what? Let's do negative 5x squared plus 2x. Yeah, let's make it fun. G of x is x plus 3. H of x is root x. J of x is, let's say, 4x plus 1. Okay. What is f of g of x, f of h of x, f of j of x, and finally, the big one, f of x. That one is not easy or obvious, but just give it your best shot. Alrighty, here's hoping that this homework goes well and that we are rolling along with composite functions. If anything doesn't make sense, just swing into my office hours. A surprisingly small number of people are taking advantage of them. I'm actually only seeing people maybe 30 minutes of the 2 hours each day that is allotted for helping students. So if you have any questions, just come on down. If there's someone there, just wait a little bit. I will almost always guarantee you'll be seen within 10 minutes. So at least so far, that's the way it's been. So come on down to office hours if you have any questions, and we will clear them up. Alrighty, have a good day and stay safe. Bye-bye.